The relationship we are going to talk about now is the relationship between volume and temperature. This relationship is expressed and it came into place very nicely in what we call Schall's experiment. Jacques Schall was a French scientist who prepared a series of samples here, and as you can see in the picture, you have some uh, air trapped in here. This mercury plug is allowed to go up and down, and notice that the pressure is constant throughout the experiment. So what Charles saw is that with a heater or with ice, he was able to change the temperature that he was able to record, and therefore he was also able to record the volume. So he saw a relationship between temperature and volume. And that's what he saw. He saw that temperature and volume are directly proportional. Okay, this means, let's put it in a mathematical form, is that volume is a constant times temperature. This constant may not be necessarily the same as the constant of proportionality between pressure and the inverse of volume, like in the Boyle's experiment, but he saw a straight line. What he saw as well, and as you see in this graph, is that depending on the number of moles of air that you would put in this a small tube, you would have a different slopes. So this constant is related to the number of moles. Of course, he was not able to put it under, in this case, under the 0 Celsius, okay? But he saw that all these points pointed to a common point in here, which it's an indirect way to figure out the origin of temperature. So while Schall's experiment allows us to know the relationship between volume and temperature, it also tells us it's also pointing to the origin of temperature, even though in the experiment you would never reach these kind of temperatures. But if you assume that there is a linear behavior between volume and temperature, this line will go all the way to 0 volume, and that's what as low as temperature can get. That's the Schall's experiment. What kind of observations in our daily lives exemplify Schall's law? What kind of observations exemplify that when you increase the temperature, you are increasing the volume in a linear fashion? That is, if you double temperature, you're going to see a doubling the volume. A hot air balloon, for example, is a clear case of Schall's law, in which what you're doing is you're increasing the temperature of the air. Therefore, if you're increasing the temperature of the air, you're increasing the volume of that air. Therefore, the density of the air, being density mass over volume, you are increasing the volume. Therefore, the density is decreasing. And because the density of the air is decreasing, this will make the hot air balloon going up. Another very graphical example is the collapsing can. I encourage you to click on this video if you go to the PowerPoints that I'm giving you along with this video. If you click here, you will see what the collapsing can is. It's a very graphical example of Schall's law. So let's run a problem, a specific numerical question. In this case, it's asking for, suggesting this situation in which there is a balloon, and the balloon has a volume of 2.57 liters, and the temperature is 0 Celsius. Okay, at a constant pressure, and that's important to keep in mind. Schall's law is only true when you keep the pressure constant. We warm up the balloon, okay, so volume 1 and T1, and then we warm it up. We warm it up to an unknown situation until the volume is 2.8 liters. Now, does it make sense that if we warm it up, the volume is increasing? Yes, because that's Schall's law. If you increase the volume, you're increasing the temperature. Okay, again, this relationship, temperature 1 is a constant times volume 1, and temperature 2 is a constant times volume 2, you can just assume that if you divide both sides of the equation 1 by equation 2, you get T1 divided by T2 CV1 CV2, constant and constant goes away. Therefore, what it's asking is T2. T2 is equal to T1 times volume 2 volume 1. All right. So that's a little bit the relationship that you need to come up with. Notice though that the temperature has to be in Kelvin. So T1 is 0 Celsius plus 273 Kelvin, 273.15. We should be more specific. 15 Kelvin. Okay, so you just substitute this in here, and then you are able to find the temperature at which you have increased this balloon so that the volume is 2.8. In this case, it's 2 at 97.6.